Okay, the next part in calculus deals with what we call the chain rule. By definition, the chain rule is if you have a derivative of y with respect to x, you can chop it up into two parts, particularly if you have a function that can be split up into two parts that are multiplied together. All right, and so theoretically, or this is the calculus speak that we use for this, if you call u a part that can be broken up from it, then you take the derivative of y with respect to that part, and then you multiply that by the derivative of that part with respect to x. Now, another way of looking at it is if you're taking two functions like f of g of x. I don't know how much you remember of multiple or composite functions in pre-calc and algebra 2, but if you were to take this composite function here, you can find the derivative of it by taking the derivative of f in terms of g of x and the derivative of g in terms of x, which is very similar to what we've done right here. Now, I'll give you an idea of what this all means here, and then I'll show you where they came up with this. In this case here, and this is kind of a refresher as to what they mean by f of g of x. In the case of find f of g of x, if f of x is x plus 5, and so this is the main function, and g of x is going to be the value of 3x squared. Well, if g of x is equal to 3x squared, then we're going to put 3x squared right here. So that becomes f of 3x squared equals, now that means the x is the value of x of 3x squared. That's going to come in and replace the x here with 3x squared. This is the x part of this part right here. If f of x is that, then that is what came from this. So we're saying that this right here is the x here that was represented by this. So we take the g of x and replace it with x, and now the other x is to be replaced by 3x squared. And so that gives us 3x squared plus 5 for our function of g of x, or function of 3x squared, same thing. Now, according to this, if I want to find the derivative of this, I would take the derivative of the f of g of x times the derivative of g of x. Well, the f of g of x when I put all this together is the derivative with respect to x of 3x squared plus 5, and 2 times 3 is 6, subtract 1 gives us x, and then this is a constant, and then we'll drop out. Okay? Now, if I were to do this right here, if I were to take the derivative of 3x squared and multiply by the derivative of x plus 5, then this is going to give me 6x times 1, which is 6x. So as you can see, they're talking about the same thing, just two different ways of doing it. And that really is key to what's happening up here. This is what they're talking about here. We take the two parts and multiply together, we get the overall derivative of the function, which is what we found right here. Now, how do they come up with that? Well, let's suppose that we have h of the derivative of h of c and we want to find out what this is. Okay, now, if we are going to assume that this is going to be the limit as x approaches c of delta y over delta x. That's what a derivative is defined as. All right, so we're looking in terms of f and g of x. Well, let me put it another way here. Let's put here h prime of c I have to cut through this, okay? Okay. So let's h of x equal f of g of x. Okay. So, so that's going to be equal to f of g of x minus f of g of c all over x minus c. And we're doing this as the limit of x approaches c. So this is our y2 minus my y1. Replace it with c, and then x minus c for my two x's. So it's a very small difference between the x's. All right? Now, this is where they have the fun part with algebra. They're now going to multiply both the top and the bottom by g of x minus g of c over g of x minus g of c, because this will have no effect upon the overall value of this right here. So we're taking, if this is the function here, then g of x is y2, and f g of x is y1. This is x2, this is x1. That's how we're defining it. Now, we're going to switch these two around here, and this is going to give us f of g of x minus f of g of c over g of x minus g of c times, and now we have g of x minus g of c over and then x minus c right here. So our definition of x and y, and y2 and y1, x2 minus x1, are then corresponding here. They take on two different dynamics here. But the result then is that because as the limit of x approaches c right here, this is then going to be the definition of the f prime, or the derivative of g of c, times, and this is the definition of the derivative of g of c, using the definition that we used earlier in chapter 2. And so that means h prime of x as x approaches c will be equal to this. And so that brings us back to where we were right here. So that's their proof for that.